In this video, we're going to look at 1 and 2. We're originally here given an exponential equation. So to graph the exponential, the y-intercept of this, or the starting value, is 1. And we have an increasing graph because the b value is larger than 1. So a sketch of the exponential will look like this. The asymptote of this exponential equation is the line that the graph is approaching but never actually intersecting, which is the x-axis, or y equals 0. The domain of this graph, all x values are on this graph, so the domain is all real numbers. However, the range is y, and there are no negative y values on the graph, so we have a range of y has to be greater than 0. It's not equal to 0 because it actually never intersects the x-axis, it just gets close. The inverse of this equation is x equals 3 to the y, but we don't usually write equations as x equals. We need to change it to y equals, and the only way to do that is to change it to log form. So log base 3 of x is equal to y. So the inverse graph is the graph of y equals log base 3 of x. To get the inverse graph, we need to reflect this graph over the line y equals x. So first let's draw the line y equals x, y-intercept of 0 with a slope of 1. So I'm going to draw a dotted line of symmetry on y equals x. And then we're going to take the mirror image of this line, and if you need to use tracing paper or a mirror, that might help, but you're reflecting this over this line, so you'll end up getting the inverse graph looking like that. And then let's answer these questions here for this equation and this graph. The asymptote now, the graph is approaching the y-axis. The equation of the y-axis is x equals 0. The domain, the x values of this graph are only positive numbers. We don't have any negative x values, so x is greater than 0. The range is all real numbers because the graph's going up and down in both positive and negative directions. Now let's look at another example here of an exponential graph. So y equals 1/2 to the x. This also has a starting value of 1. So y-intercept of 1, but it's decreasing because b is less than 1. So we're going to draw our graph decreasing. And the asymptote here is still the x-axis, so it's still y equals 0. The range, or the domain, first is all real numbers again because it's covering all values of x. And the range is all numbers greater than 0, so y is greater than 0. Now let's look at the inverse equation. So we have, if we switch x and y, we have x equals 1/2 to the y, which rewritten is log base 1/2 x is equal to y. So the graph of this inverse equation will be the reflection of this graph over the line y equals x again. So this portion of the graph, when reflected, will be over here. And this little piece of the graph, when reflected, will be up here. So we can see here this log graph has an asymptote again at the y-axis, so x equals 0. The domain of this log graph is all positive numbers, so x is greater than 0. And the range is, again, all real numbers.